Applied Biosystems, now part of Thermo Fisher Scientific, released the first commercial qPCR instrument in 1996. As the technology approaches 30, I spoke to Senior Director of Product Management Damien Luk about what he sees for its future and how the company plans to continue innovating. What trends are you seeing among qPCR manufacturers now? What do you see for the future of the technology?
qPCR is probably the easiest genomics technology out there to use. However, you still need the ecosystem of the reagents and the primers, the probes, all the chemistry details and the plastics. And then you need the software and the integrated LIMS systems. And then you have to worry about cybersecurity and all of these things to make it easy for the person in the lab to get to their results. The trend is, and what we're tackling is integrating some of the consumer-based products that you see out there, some of the functionalities to how do you quickly take knowledge that you may be aware of from your phones and computer devices to say, how do I quickly get my answers without going through the traditional steps of, well, let me go fill out a whole stack of paper, sign things over here, and then manually pipette 20 times and keep track of what I pipetted where, to how do you automate some of these things, not only from a machine perspective, but from a mind perspective. And that's kind of the premise of artificial intelligence and some of these things that are coming out in the world, and how do we, as a manufacturer like Thermo Fisher Scientific, help provide even more advanced capabilities to make qPCR even simpler, faster, and easier for our customers in the lab to go run and get results for. So our investments have really centered around the workflow to make that as simple as possible for the lab bench that honestly the users spend most of their time on. So we actually want the customers to spend the least amount of time looking at their instrument and then quickly get results from their data so that they're minimizing their time spent on preparing samples. Our products and our solutions are meant to work well together. So there's nothing wrong with combining the best of everything that you can find. But when you're using everything that's designed and built together, it's just simpler that you can pick up the phone and call one of our field application scientists or service engineers who can say, here's the 3 steps in order to get to your result.
Mm-hmm. And I imagine with a lot of the connectivity capability, you mentioned that there have been some cybersecurity developments in the space. Could you talk about that a little bit?
The cybersecurity is a very important aspect of what we need to provide to our customers. There are expectations from our customers that the instrumentation, the software ecosystem that we provide will adhere to a level of standards based on various regulations around the world. We're proactively and constantly looking at vulnerabilities in our platforms, and we've got a lifecycle management of making sure that our software meets those standards on a continual basis. We also need to retire some of our older products because they just don't have the capabilities to deal with the cybersecurity concerns that continues to evolve. The consequence of the post-pandemic outlook is that the supply chain that we have created, as well as the engineering that we have created for the infrastructure of the platform, requires the ability to quickly adapt to electronics that may be going end of life. As you recall, and probably all of us recalls, is during the pandemic, it was very difficult to obtain refrigerators or a lot of the electronics because of what we call chip shortage. Supply was short, not because some of the metals was not available, but because some of the electronic chips was not available to run the instruments. And we, like all others, were also impacted by those events. So what we do is we deploy strategies with our supply chain to make sure we have sufficient supply with our vendors. We also make sure that our design can rapidly create a like-for-like replacement for some of these electronics, so that if there's an event that requires us to provide the exact same functionalities of the instruments, we can quickly migrate to the new chip so that the platform continues to be produced at our factory. So that requires a fair amount of engineering smarts from our team to create that scalable architecture.
How does Thermo Fisher Scientific handle the life cycle management of instruments that are getting phased out?
Yeah, Colin, when we look at the products that we provide, we always consider how do we provide the longest duration that our customers can have using our products safely and effectively. And what I mean by safely, that refers to some of the conversations around cybersecurity. Is by design, the older products have a higher level of concern. And the last thing we want to do is have our platform be that mode of transportation for some of these activities from bad people. We have programs called trade in or trade up. We're very diligent at looking at the environment to make sure we can reuse or recycle. But we have these programs in place really to drive the utilization and the newer and technology, again, that's safer and more effective. But at the same time, do it in such a manner that we would be very happy to take the customer's old instruments back to our resource location that will recycle or refurbish some of these for other customers that may want to use refurbished instruments, or if we're not able to do it in a safe and effective manner, then we will recycle them in a safe and effective manner.